Hey guys, it's Mr. Zimmerman, and today we're going to look at some of the application problems in our review guide. So let's go ahead and jump in and see when we can use exponential functions in the real world. So I just want you to know that the basic form of most of these are that the function is going to be in terms of t, where that is years, and it's always going to be the initial amount, and we're going to multiply it by 1 plus or minus the percent in decimal form, and we're going to raise it to t years. Now, since this is a savings account, we know that this is going to be a 1 plus r. Essentially, you have to decide, remembering that when it is bigger than 1, it is going to grow, and when it is less than 1, it is going to decay. So when I have 1 plus 0.00, just 0.04, that is going to be what's going to be inside the parentheses. So let's write this equation for this application. And the initial amount deposited is $1,000. I'm going to have 1.04, and it is going to be raised to the t power. Now to the nearest set, how much money will be in the account after 18 years? I'm going to go ahead and plug in 18 years for t. So what I would have to input into my calculator is 1,000 times 1.04, and I'm going to raise that to the 18th power, and that will give me my answer. And as long as I round to the nearest cent, I'm good to go. So my nearest cent, just for example, if I had $1.567 has 2 decimal points, this 7 would cause me to round it up, making it $1.57. Let's go ahead and jump to another application problem. So in 2005, there were cell phone subscribers, and it increases. This is indicating that be 1 plus r. So my function is going to be my initial amount, which is 285 times 1 plus the decimal version of my percent. I'm going to move it over 2 spots, so it's going to be 0.075, and I'm going to raise it to t years. Now I can simplify it by just rewriting it one more time, and I'm going to just write the inside of the parentheses as one number so I don't have to do a sum. Voila! Now, to the nearest whole number, how many subscribers will be there in 2020? Now, 2020, this is since 2005, so 2020 minus 2005 is going to give me 15 years. So I need to go ahead and plug in 15 equals 285 times 1.075 to the 15th power. Just remember, for this answer, since we are talking about people, you're going to have to round to the nearest whole. Go ahead and use a calculator to get your answer. The final part is, Detroit, and it's decreasing, so we're going to have to do 1 minus r. So my function in terms of t is going to be my initial amount times 1 minus the decimal version of the percent, so it's 0.0127, and then it's going to be raised to the t power, and I can simplify this by rewriting this times the difference. I use the calculator. 1 minus 0.0127 is going to result in a difference of 98.73 to the t power. Now to the nearest whole number, because we're talking about people, what will be the population of Detroit in 2030? If I go ahead and look, I see that 30 years have passed by from when this equation started. So my function, I'm going to substitute 30 in. and then I'm going to raise it to the 30th power. And then I'm going to just make sure that whatever number I get, I round to the nearest whole because I'm talking about people. So this was just a look at one type of application problem that might show up on the study guide. I hope that this kind of helps. Just recall in the beginning where I looked at the formula, the initial amount is 1 plus the percent, and just remember that the percent is always in decimal form. That's it for now.